So I'm just wanted to provide an overview. I think I'm still sharing my screen. An overview of the greedy paradigm for making an algorithm. So the idea with the greedy paradigm, and we've seen this before, and I'll show more examples today. But the idea with the greedy paradigm is that you are building up a solution to your problem by making sequential choices. So you're making one choice after another. Like basically you're building up a solution from partial solutions or from component choices. So not every problem has this structure, but lots of problems that we deal with have this structure where you can think about a whole solution as being made up with a bunch of pieces. Second of all, in the greedy paradigm, we assume that there's some way of determining if I have a particular partial solution, what are the choices that are feasible, or what are the choices that are allowed given the choices that I've already made. So if I'm partway through solving the problem, some choices may no longer be allowed. Again, I think of like if I'm scheduling putting fall classes into classrooms, right? So if I'm putting fall classes into classrooms, you can think about this as being a repeated choice problem. I put Intro to Python into a room, and then I put Calculus 1 into a room, and then I put Dealing with Data into a room. But after I've made some choices, the choices I've made in the past may result in some things no longer being allowed. Like once I've put Dealing with Data in HNS 168, I can then not put a chemistry class into HNS 168 at the same time. So some choices become unallowed given what I've done before. And then the final part of the greedy paradigm, and this is kind of like the key to the greedy paradigm and what really sets this apart from other ways of solving problems, is that at any step, I can evaluate how good or bad each choice is. So how valuable is it? How good is it to how good is it to put Intro to Python into Che Auditorium? And maybe again for the class scheduling problem, maybe the goodness would be related to like what is the capacity for the room and how big is the class? Like it would perhaps be more good to put a big class like Intro Python into a big room like Che Auditorium instead of putting like a small class like Advanced Algebra, or not Advanced Algebra, Abstract Algebra. A small class like Abstract Algebra would probably be less good for a large classroom like Che Auditorium. So the idea with a greedy algorithm is that every time I have to make a choice, I look at the goodness of all of my allowed choices, and I pick the one with the best goodness. Choose the allowed feasible. Okay. Right, I'm choosing from among the allowed choices that I have, I'm just choosing the one with the best goodness. So this is a really like easy, straightforward way of designing an algorithm. And it comes up in a variety of cases. We've already seen some examples in this class. And so I'm going to go over some examples in just a minute. But first, I wanted to give people an opportunity to ask any questions about the general outline of a greedy algorithm. Let's see what's okay. Okay, so the first example, which we talked about at the beginning of this class, was sorting integers. So the idea was we wanted to, for the selection sort algorithm, the idea is we wanted to sort a list by repeatedly choosing what is the next item to put into the list. So I start out with an empty list. I'm trying to build up a sorted list by putting in numbers one at a time into my sorted list. So this is like part one of the greedy algorithm. I need to go and squint a little bit and see the sorting problem as making repeated choices, one after the other. Then the second thing is, okay, what are the allowed choices? So if I'm partway through sorting my list, the allowed choices is I can choose any number, choose any item in the list that I haven't yet used. So once I go and use a number, once I go and put a number first, I can no longer use that number and put it somewhere else in the list, right? That's pretty straightforward. And then the goodness of a number is just the value of the integer. So the number 11 has a goodness of 11. The number 3 has a goodness of 3. So selection sort says to sort a list, repeatedly grab the unused item with the best goodness and stick it in. So if I had like 3, 1, 8, 11, 7, I would first choose 11 because that is the best, the most good element. And then I'd choose 8, and then I'd choose 7, and then I'd choose 3, and then I'd choose 1. So I end up with the sorted list 11, 8, 7, 3, 1. Right? So this is a greedy algorithm. We call it a greedy algorithm because it follows this pattern of always picking the most good thing that you have available at a given point in time. So anyway, I think this is an example we've seen before. I'm going to do one more example that we've seen before, which is Kruskal's algorithm for minimum spanning tree. So Kruskal's algorithm, this was one of the yarn algorithms that we did, where we started with the shortest piece of yarn and put that into the tree. Said, okay, if we want to connect people as cheaply as possible, let's go and take grab the shortest yarn, put it in our solution. Then after we've started picking pieces of yarn, the allowed choices are the choices that don't form a loop, right? The idea for minimum spanning tree is to connect everyone without forming a loop. So at each step, the allowed choices are any of the edges that don't form a loop, and we want to pick the edge that has the lowest cost. So again, some problems are maximization problems where you choose the most good, and some problems are minimization problems. Right, maybe I should even write this. So maximization problems pick the most good choice, and minimization problems, we want to pick the least bad choice. So minimum spanning tree, we are picking the least bad edge over and over again out of the allowed edges, which are the ones that don't form a loop. So this is a minimum spanning tree algorithm that we've seen before, and this is how it fits into the greedy paradigm. So next I'm going to go and give another example that you haven't seen before. But first, I just want to give people an opportunity to ask questions.